Hi everyone, Assalamualaikum. I am Miss Hidayu. I'm going to explain for chapter 2, which is atomic structure. So let's take a look at the learning outcome for this chapter. At the end of the lesson, students should be able to describe the properties of proton, neutron, and electrons in terms of their relative charges and relative masses. Describe the distribution of mass and charges within an atom. Define the proton number, nuclear number, and isotope. I think you might be familiar with this term because you have learned this during your secondary school. So next, you need to know how to determine the number of proton, neutron, and electron present in both neutral and charged species of a given proton number and nuclear number. So state the mass number and number of neutron for a specific isotope. Write isotopic notation. So generally, isotopic notation is written as X. X is any element in the periodic table. And we have A and Z. So A is the mass number or nuclear number. We know for Z is the atomic number or proton number. Okay, next any outcome, you need to know how to define the terms relative atomic mass, or the symbol is AR, relative isotopic mass, relative molecular mass, and relative formula mass based on a carbon-12. Last but not least, you need to know how to calculate the average atomic mass of an element given the relative abundance of isotopes or a mass spectrum. Okay, as an introduction, atoms are the building blocks that make up everything. For example, table, water, and gas. So atoms are very tiny or very, very small in size. So now let's see what is inside the atom. Here we have the atomic model. So at the middle or in the center of the atom, we have nucleus. So inside the nucleus, we have two tiny particles called as proton and also neutron. Outside of the atom, we have electron. So this electron moving around the nucleus in orbital with high speed. So these three tiny particles are called as subatomic particles. So the electric charge of proton is positive or positive 1. On the other hand, the electric charge for electron is negative or written as negative 1. So neutron have no electric charge at all. So therefore, it is written as 0. So it is neutral. So the mass of proton and neutron are very, very similar in size and mass. So it's about 1.67 times 10 to the power of negative 24. So same as neutron. So since the number or value is very small or tiny, so scientists come up with another way to measure the mass of proton, neutron, and electron by using the atomic mass unit, or the symbol is A and U. So it is can written as proton and neutron has 1 AMU, atomic mass unit. So if we look at the electron, so the mass of electron is smaller than proton and neutron. So the mass is only 9.1 times 10 to the power of negative 28. So it is very small. So mass of electron is 0.0005 AMU. So it's easy to use this measurement in atomic mass unit compared to the scientific notation like this one. Okay, we continue with the distribution of mass. So Ernest Rutherford proposed that atoms consist of very small and very dense positively charged nucleus composed of two tiny particles, which are protons and neutrons, surrounded by the electron clouds of electrons. So the mass of atom is its nucleus occupy only a very small portion of the space of the atom. So nuclei have diameter around 1 over 10,000 to 1 over 100,000 times less than the atom's radius. So here is the figure of atomic structure. So in the middle, we have nucleus. So inside the nucleus, we have neutron in yellow color and also proton in red in color. So proton have positively charged. Neutral have no charge, which is 0. That's surrounded by the electron cloud, which is contain electron. So move in orbital around the nucleus, then electron have negatively charged. So that's why neutral atoms has no charge because attraction of electron or attraction between negatively charged and also positively charged, then will give you 0, then you get neutral atoms. Okay, then we look at the proton number and nuclear number or mass number. So mostly realize that the elements are determined by the atomic number, which differ from each other by the number of protons in the nucleus. So as you can see, the modern periodic table right now are arranged by using proton number from left to the right with increasing proton number. So the atomic number is actually the proton number in the nucleus of an atom. So proton number or atomic number was written or given the symbol Z or Z. Okay, meanwhile, for mass number or nuclear number, the symbol used is A. So the number of electrons in a neutral atom is also equal to the atomic number, meaning that if that atom is neutral, so the number of electron and the number of proton are the same. So nuclear number or mass number, written as A here. Here is the total number of proton and neutron. So you can use this formula to calculate the nuclear number. A is equal to Z plus N, where A is the nuclear number or mass number, and Z is the proton number, and N is the neutron number. So on the periodic table, the atomic number is in the uppermost number in each element in the box. Okay. So let's see this one. Okay, this is the general isotopic notation where E or X is the element in the periodic table. A is the mass number or mass number or nuclear number. Z is the proton number or atomic number. Okay, so if you see the periodic table, so it's like this one. So CD is the symbol of the element. Then yang dekat atas ni, so the uppermost number here is the atomic number or Z, which is proton number. And at the bottom here is the atomic mass. So right now, let's differentiate between atomic number and atomic mass. So atomic number is the proton number in the nucleus of an atom. Whereas atomic mass is the average of all different type of isotope of that element. Okay, so let's move on to the isotope. Alright, so isotope is the atom of the same element but with different neutron number. So a particular isotope of an element is identified by a specifying its atomic number given the symbol Z and its mass number A. So here we have two examples, which is hydrogen isotope and also oxygen isotope. So the element is the same, but the proton number also the same, but it is different in neutron number. So here we have 1 hydrogen or protium, 2 hydrogen or deuterium, and 3 hydrogen or tritium. So the number of proton are the same. So as you can see here, 1, 1, and also 1. Okay. So the number of neutron for protium is 0. For deuterium is 1 and tritium is 2. So protium is the most common isotope in the earth. Then the second most abundant is deuterium and tritium is the radioactive element. So next example, we have oxygen isotope. So we have oxygen 16, oxygen 17, and oxygen 18 with the same proton number, which is 8, but different neutron number. So for oxygen 16, it has 8 neutron number. For oxygen 17, we have 7 proton number. And for oxygen 18, it has 10 neutron number. So the percentage abundance for each of the isotope, so you can refer to here. So this one is the most abundant table, so 99.76%. So least abundant 0.04. So one the second most abundant, so give you 0.2%. So isotope is like for you to understand, it's like, okay, I'll give you an example. Okay, we have one person. Let's say that person we call as person A, or okay, we have Abu. So on 2018, the weight of Abu was 50 kg. Okay, so a year after that, on 2019, the weight of Abu become 60 kg. So up until right now, on 2020, so the weight of Abu become 50, 60, 80, for example. So right now, Abu is still the same person, but with the different weight of the body. Okay, same like isotope. So isotope is the same element. So let's say we have hydrogen, so same element, but different neutron number. Okay, let's see an example. So here, example 2.1. Determine the proton, electron, and neutron number for the isotope. So we have element chlorine with 35 mass number, and proton number is 17. Another isotope of chlorine is 37 mass number and 17 proton number. So how to determine this one? So first, you already know the proton number for each of the isotope. So the proton number of chlorine 35 is 17. Okay, next. So this one is the neutral atom. The neutral atom have the same number of proton and also electron. So you know the number of electron for chlorine 35 is also 17. Okay, right now we want to calculate the neutron number. So by using formula, A is equal to Z plus N. Okay, you want to calculate N right now. So you have the value of A, which is 35, equal to, you have also the value for Z, which is 17, so plus N. Then calculate. So N is equal to 35 minus 17, then you will get 18. So for isotope 35, the number of neutron is 18. So same goes to the chlorine 37. Use the same step as previous one, yang tadi tu. Okay, so you know the number of proton is 17. So since this one is neutral atom, so it has the same number of proton and electron. So to know the number of neutron, you use this formula. Then you will get 20 neutron number. Okay, next example, example 2.2, determine the proton, electron, and neutron number for the charged species below. Okay, so this one, charged species, meaning that ions. So this one is ion. So we have two example here, nitrogen 3 minus and also aluminum 3 plus. So this nitrogen has mass number 14 and proton number is 7. For aluminum, mass number is 27, proton number is 13. Okay, so you know already the proton number for nitrogen is 7. Then the number of electron. Right now, this one is ion. So negatively charged, meaning that this element receive an electron. So berapa banyak yang diterima? How many electron that this element receive is 3. So you just plus 7 plus 3, then you get the number of electron is 10. So how to calculate the number of neutron? By using the same formula. So A is equal to Z plus N. Okay. Right, so Z is 7. So this one is 14. And 14 minus 7, you get the number of neutron is 7. Okay, same as aluminium. Same calculation used as aluminium. So the number of proton is 13. So number of electrons, so this one is plus. Meaning that this element or this atom donate 3 electron. So you just minus 13 with 3, then you get number of electron is 10. So use same formula to calculate the number of neutron. Okay, so next we have relative atomic mass. So as you know, each element in the periodic table like sodium, potassium, nitrogen, and so forth has its own atomic mass. So relative atomic mass is the average of all different type of isotope of that element. So let's recall back what is isotope. So isotope have the same number of proton and also number of electron. However, they do not have the same masses. So they have different mass and different number of neutron. So mass of atom and their subparticle are expressed in atomic mass unit, which is AMU. An atomic mass unit is exactly 1/12 of the mass of a carbon atom that has 6 proton and 6 neutron in its nucleus. The mass of carbon-12 has exactly 12 atomic mass units. Then it is possible to establish a relative weight scale for atom. So we can say that 1 AMU or 1 atomic mass unit is equal to 1/12 mass of carbon-12, or 1 atomic mass unit is equal to 1.66 times 10 to the power of negative 24 gram. So this is the mass of proton and neutron. So to calculate the relative atomic mass, we can use this formula, which is relative atomic mass is equal to mass of one atom of n element divided by 1/12 times mass of one atom of carbon-12. Let's see the example. So we have example 2.3. Determine the relative atomic mass of an element Y if the atomic mass ratio of Y to carbon-12 is 3.25. So we already know, already given in the question is the relative atomic mass of Y, which is 3.25. By using the formula, relative atomic mass is equal to mass of one atom of Y divided by mass of one atom of carbon-12. So we substitute the relative atomic mass to 3.25. Therefore, mass of one atom of Y is equal to, so we bring this one to here. So the mass of one atom of Y is equal to 3.25 times with mass of one atom of carbon-12. So, masukkan semula dalam formula. So, relative atomic mass of Y is equal to 3.25 times mass of one atom of carbon-12 and divide by 1/12 times mass of one atom of carbon-12. So, as we know, mass of carbon is 12. The mass of one atom of carbon-12 is also 12. So 1/12 times 12, we will get 1. Then here, 3.25 times with 12 divided by 1, then we will get 39. So, if you look at the periodic table, then the relative atomic mass of Y is 39, is referring to the potassium atom. Okay. The other way to calculate relative atomic mass is from isotopic abundance. So the masses of atoms and molecules can be determined by using a mass spectrometer. So this is the figure of mass spectrometer in 2D. So as you can see here, there are 4 parts in mass spectrometer. Okay. So what happened in the mass spectrometer? So the gaseous substance is injected into an evacuated chamber, which is this one. So atoms or molecule are ionized in ionization chamber. This is the first part. Ions are accelerated through an electric field and pass through 2 slits to produce a narrow beam. So it goes to the second part. So next, the beam is deflected in the magnetic field towards a collector plate. So the deflection of ion depends on the masses and charges. So the third part, which is the deflection. So the greater the positive charge and the smaller the mass of an ion, the more it is deflected. So by varying the strength of the magnetic field, ions of the different mass can be focused progressively on a detector. So detector identify the mass of each ion from its part. So data will be recorded as a mass spectrum. So that one is the last part, which is detection. So this is the figure of mass spectrometer in 3D. So later I will put or embed a video from a YouTube for you to see the process in mass spectrometer clearly. Okay, so given here is the data, example of data collection from mass spectrometer. So we have 2 axes here. The y-axis represent the relative abundance and the x-axis here represent the mass of that ion. So here is the mass spectrum of neon ions. So the peak here represent the relative abundance for each isotope. So we have isotope 20, isotope 21, and also isotope 22. So from the mass spectrum of neon, we know that isotope neon 20 with a mass 20 AMU, the relative abundance is 0.9048. Next, isotope 21 for neon with a mass 21 AMU, the relative abundance is 0.0027. And lastly, for isotope neon 22, the mass is 22 AMU and the relative abundance is 0.0925. Then how we want to calculate the average atomic mass from the isotopic abundance given. So we can use this formula. Average atomic mass is equal to the total mass of all isotopes in bracket AMU divided by the total abundance. So to calculate the total mass of all isotopes, what you need to do is take the isotopic abundance from the data collection times with the mass of that isotope. So we have isotope for neon 20 plus with neon 21 plus neon 22. So the total mass of all isotope for neon 20, the mass is 20 and the isotope abundance is 0.9048. So we times these two, then we plus, because here the formula is total. So plus with the isotope neon 21 plus with isotope neon 22, then divide by the total abundance, which is this one. Total up all the isotopic abundance given in the equations, then we get 1. Then selesaikan this one, you will get 20.1877 AMU for neon. So this is the average atomic mass of neon. So you can refer to the predict table as well. Okay, let's see another example. So we have example 2.4. Naturally occurring vanadium consists of two isotopes. It is 0.25% of vanadium 50. The first isotope is vanadium 50 with a mass of 49.95 AMU and 99.75% of isotope vanadium 51. So this is the second isotope, which has the mass of 50.94 AMU. Calculate the average atomic mass of vanadium to 1 decimal place. So what you can do here, use the formula average atomic weight or average atomic mass is equal to the mass of isotope vanadium 50 plus with isotope vanadium 51, then divide by total abundance. So to calculate the mass of all the isotope, you have the isotopic abundance here. So you can see here what you need to do. First, convert all the percentage to decimal by dividing by 100. So divide by 100. So 100 have 2 0. Then you boleh pindahkan ni 1, 2. So you will get 0.0025 times with the mass, which is 49.95, plus with the isotope of vanadium 51, and divide by the total abundance, you will get 50.9 AMU for the vanadium. So you can refer back to the predict table of vanadium. Okay, here I leave the exercise for you to do. Then you can check the answer with your lecturer. Thank you.